Hi guys, um, we are going to deal with the stress analysis of a rectangular L bracket in ANSYS. So we'll see the design first. So this is the design, and this is the degrees of freedom that is constrained, and this is the load that we are going to apply. So first I will open the ANSYS APDL. So first we'll go with the preferences that which analysis that we are going to do. So this is structural, okay. And go to the preprocessor, select the element type, add, edit, delete. So we are going to add the solid element. So solid we'll be having quad 4 or 8 noded. There are many type of elements, but we can either select quad 4 node or 8 node. Okay, I'm going with quad 4 node 182 element. Okay, and we need to go with the K3 element behavior, that is plane stress with respect to the thickness. So click OK and close. So after element type, we need to go with the real constants where we need to give the thickness of the element. So click OK. So here we need to give the thickness which is 0.5. Okay, one second. Yeah. So here is the thickness that they provided in the procedure. So yeah, this is the thickness 0.5. All the dimensions will be in mm. So close this and go to the material properties, material models, and go to the structural, which we are doing is linear elastic type, isotropic material properties, or um, that is 2e5 and 0.3. The Young's modulus is 2e5, and the Poisson's ratio is 0.3. Click OK. So and close this, and now we need to go with the modeling. So here the modeling we need to go with see in the procedure PDF we have only the dimensions which is not possible to design. We need the key points, so where the edges should be we need to capture. So here I generated the key points. So this is first key point, second key point, third, fourth, fifth, and sixth. So in this way we need to go with the modeling. So create key points in active CS. So the first point is 100 comma 0. We can skip this. If it is blank, it will be taking as a 0. Apply. And the other one is 150 comma 0. So I'm leaving it as blank. Apply. And after this, the third point is 150 comma 100. So apply. And the fourth point is 0 comma 100. So this is y, this is z. Okay, this will be x. Apply. And 0 and 50. Apply. And this will be 100 and 50, and this is going to be the last point. Okay, so here I am zooming out, you can check. So 1 2 3 4 5 6. Okay, and after this we need to go with the areas. We can go with arbitrary through key points. So select first point, second point, third, fourth, and fifth. Oh my god, so I'm going to cancel this and again need to select. Okay, select carefully first point, second point, third point, and then fourth point, and then fifth point. Okay, and then sixth point. Click OK. After this, it is automatically uh, going to be a filled area. Okay, and after this we need to go with lines. In lines we need to create a fillet here. Okay, with the 10 radius, 10 mm of radius lines. sorry, it's not lines, it's line fillet. Okay, select this line and this line. Okay, here easily we can create a fillet. Okay, it is taking as the intersecting lines 5 and 6, and the radius will be the 10 units. Click OK. So after this we need to create the area. Okay, so again we need to go to the areas, arbitrary, through lines. Okay, here we have lines. First this arc and the top edge and the right edge. Okay, click OK. After this we need to create circles, solid circle. So here we need to create a circle at with the center. Okay, center and radius. So the center will be from here to here, it is 100. So till here it will be 75. So x is 0, y is 75, and the radius will be 25. Okay, and again solid circle. So here now we need to go with 125, and y is 0, and here the radius will be 25. Okay, so now we created the areas. Okay, now before creating the whole we need to boolean. Okay, we need to join all the circles and the rectangles, I mean the areas. Okay, here this is different, this is different, and this is different. So we need to operate booleans. Okay, and we need to go with add areas. Okay, pick all, we can go with pick all. So now it is a single unit that we can go. Okay, before getting into, we need to create whole again. So for that we need to create areas, circle, solid circle. The x value will be same. Okay, 0. Y value will be 75, and the radius will be 12.5, which is 25 dia. Okay, click OK. Yeah, next again solid circle. Here we need to do, that is x is 125, y is 0, and the radius will be 12.5. Okay, now we need to do again the boolean. So we need to go to operate booleans. Now we need to subtract. Okay, subtract areas, subtract from the entire. Okay, okay, subtract this one and this one. Okay, click OK. Done. So the modeling part is completed. Now we need to go with meshing. Mesh tool, select the smart size and put this fine size as 3 or 4 or whatever you want to be. Yeah, select areas, set, and pick all. Okay, the edge element we need to give is 4 or 5. I'm going with 4. Okay, and rise hidden. Select this mesh, pick all. That's it. The entire, I mean, there will be some warnings, no issue, because those warnings are like these, all the mesh is going to be rectangular, right? At the circular edges or I mean the fillet areas, it is going to be some kind of changes. Okay, rectangular. You can see here, it is a rectangular mesh. Okay, that is there. It is going to, it is giving the warning. Just skip it and go to loads. Okay, you will be having the loads in the preprocessor as well as solution also. Okay, define loads, you can go with define loads, apply structural displacement on lines. Okay, you can select all these quadrants, I mean the lines as the edges of the circle. Click OK, and all the degrees of freedom you need to fix. Okay, fine. And now the pressure that we are going to give here. We will see the load. What is the load it is giving? 50 kilonewtons. Okay, that should be in the negative way, because it is not a force. We are creating the pressure towards downward. Okay, so we need to select pressure on lines, select this line and this line. Okay, here pressure value should be minus 50. Okay, no, it should not be minus, it should go down, right? So I'm deleting the pressure, structural pressure on lines, select these two pressures. Okay, now it got deleted, and again we can go with the apply structural pressure on lines, select this one and this one, click OK. So it will be positive only, no issue. Click OK. Fine, the arrows should be towards outside. And go to the solution, solve current linear load step. Okay, solution is done. Close and close this as well. To view the results, go to general post processor, plot results, counter plot, nodal solution. Okay, before that, we'll see the deformed shape, deformed plus undeformed. Okay, this is how it is going to be deformed. Okay, with the maximum deformation is 0.7345, and we'll see the uh, stress factor that is going to be applied. So to see the stress factor, plot, counter plot, nodal solution, go to stress. Here we need to go with one Mises stress. Okay, so this is how it is going to be. To view this one in a solid format, I mean in a 3D view, go to plot controls, style, size and shape, select the option display of element should be on, click OK. So you can see the thickness, right click and drag. You can see the thickness as 0.5 mm. Okay, and again I'm zooming out, or else we can use this fit view. Okay, fit view and plot controls. You can go with the animate, deformed results, stress in the x direction or y direction. We can select both the directions or whatever. Okay, click OK. So this is how it is going to be in the y direction. Okay, so that's the end of the exercise. Thank you.